welcome back to the channel. Today we are going to solve this amazing question on the Codeforces called T testing, which is division 2 C question. So let us head to read it. So a tea manufacturer decided to conduct a massive tea testing. N sorts of tea will be tested by N testers. Both the sorts of tea and the testers are numbered from 1 to N. The manufacturer prepared AI milliliters of the ith sort of the tea, and the jth taster can drink at most BJ milliliters of the tea at once. Now the tasting will be conducted in steps. During the first steps, the ith taster tastes the ith sort of tea. The ith taster drinks minimum of AI, BI of the tea, how much is available of the ith sort, and how much the ith taster can at most drink. So AI also decreases by this amount. So in the next steps, the tasters shift their position by one to the left, and the first taster finishes their testing. So basically what is happening is that let us take a look at this first sample test case, and finally we have to output how much every taster has drank. Okay, so let us consider this test case. So test case is like this: n is equal to 3. First element of A is 10, then second is 20, 15, 9, 8, 6. So here in the first step, this guy will drink 9 milliliters of tea, right? So and this will drink 8, and this guy will drink 6 milliliters of tea. Finally our condition of the array will be 1, 12, 9. 9 shift means the tasters shift by 1 to the left. So this guy has completed its testing and has drunk 9 milliliters of the tea. Now in this step, this guy is this guy will finish his tasting and will eat 9 milliliters of the tea in the total, because he has drunk the 8 milliliters in the first step, and he will drink this remaining one in the second step. And about the 6, in this step also it will drink 6. So finally it it would have drunk this 6 milliliters plus this 6 milliliters, 12. So our answer array should be 9, 9 and 12, which is indeed correct. So let us take a look at this example test case. Here we can notice that 3 3 is the first taster. So after first step only his job gets finished. So first taster will drink 3. Then this taster, see, he will drink 4 from here. So the state will be, after first state, 10, 4, 3, 3. And first tester has finished its testing. Then 4, 2, 1, and everybody has drank to their limit. So the answer array for now is like 3, then 4, then 2, and then 1. Then after this second step, this guy will also drink 4 milliliters of tea. Then answer array will be updated to 8, 8. This guy will also drink to its limit, this guy as well. So 4, and this one 2. So after the second step, the array of the t's will be like 10 minus 4, which is 6, 4 minus 2, which is 2, 3 minus 1 is 2, and then 3. This taster would have finished its testing. So this is our final state, and after this state this drinker will finish its tasting. So finally 3, 8, 4 plus 2, 6, and for this guy, he will or she will drink to her or his limit again. So 1 plus 1 is 3, 2 plus 1 is 3. Then in final step our array would be like 4, 1, 2, 3, and first means last taster will be shifted to this position, and again it will drink to its limit. So our answer finally will be 3, 8, 6, and 3 plus 1, 4. 3, 8, 6, and 4, which is indeed correct. And similarly you can verify for this for last test case as well. So what I can do here is that solve the question. Let's copy this test case. 3, 10, 20, 15, 6. So what will I do is that this question covers one interesting concept called delta encoding, which is a really nice concept to save the time complexity or time. See, we will take a look at it. So what I will do is that I will build the prefix sum for the B array. This is our A array, this is our B array. So prefix sums will be looking like 0, 9, 17, and 23. So starting from here, suppose the ith the tree in the ith place, suppose suppose the tasters after this bi plus 1 so on up to bj drank to their limit from this t ai, and the taster bj plus 1 was not able to drink to its limit from the ai. So not able to drink to its limit from ai, so he drank the remaining tea. So first we will find that how many of them drank to their limit. Okay, to do that we can consider these prefix sums. Consider these prefix sums, so that like I will consider 10 plus 0. 10 plus 0, it will be 10, because I have to add these elements from b1 to bi minus 1 to this, right, for checking how many drinkers drank to their limit, right? So 10 plus 0 is 10. So I will find the upper bound or the upper bound in the set. I will use the set data structure to implement the solution, and I will use set dot lower bound of something, lower bound, which is very nice inbuilt function, lower bound of something, and it will give the iterator auto iterator is equal to, now this thing will give me the iterator to the element, iterator pointing to the element whose value is at least 10, at least 10. Lower bound will return the iterator whose value or the corresponding to its value corresponding to that iterator is at least 10. It can be 10 or more than 10, greater than or equal to 10. And if I use upper bound, it will be strictly greater than 10. Okay, so that is the concept of lower bound and upper bounds. And now if I consider the lower bound of 10 here, it will be this thing. So my iterator will be pointing to this thing. So how will I build the delta encoding vector? So let us take a look at that. This is my delta encoding vector. So 0, 1, second, third, fourth. So our array is of length 4, array is of length 3. I am building delta encoding like this. So what will I do is that, so what will I do is that for this first element 10, how much guys drank to their limit? Only this guy, right? So I will put 1 here, and next to that guy who cannot drink to its limit, I will put -1. Okay, -1 in the sense I'm subtracting, and here I'm adding 1. So for this 20, how many guys drank to their limit? This 8 also drank to its limit, and 6 as well. So I'll put again plus plus here, plus 1 here, and I'll put -1 here because second and third guy drank to their limit. So I'm putting -1 ahead of 3. So for this guy 15, who drank to their limit? So this 6 actually drank to its limit, and again I can put -1 here, or I can leave, but I'm putting it. So after adding, this gives the result as, here it is always 0. I am uh, initializing that delta encoding vector with all the values as 0. Then our delta encoding vector will be like, we are concerned with only this part. So 1, 2, 3, it will be like 1, 0 and 1. Then I'll take prefix sum of this delta encoding vector, and it will be like 1, 1 and 2. Then see that how the values got propagated, means this one got propagated to this and this as well. This is the uh, nice property of delta encoding vector, that it saves time. So we don't need to update the elements in the array every time, or the for the every I we perform the operation. We just need to store them first and then just take prefix sum. So it saves our time from O of n square to O of n. So what this prefix sum of delta encoding vector is saying, that this first at this index 1, it was available for, means the first guy can drink to its limit only one time, second guy drank to its limit only one times, and third guy drank to its limit two times, which is indeed true. So you can also check this for second and the last, or third and the last test case. Second test case is trivial, like 157, where trivial answer would be 5. So you can check this delta encoding method for this third and the last test case. I will leave it up to you. So basically this is the solution. So let us head to the code. See, I've included many debugging or illustrating steps to get it clear. See, you can uncomment these steps to finally how the code is working. You can understand it. So basically here input gets completed, then running sum means prefix sum. I am pushing, means I'm inserting it to the set to use the lower bound thing. And here in the for loop, I am doing this iterator to prefix uh, this pr set dot lower bound of temp. And if it is at end, we will just do delta encoding of I plus plus. We saw here, right? It is no need of this fourth index, right, for the delta encoding. This is just the trash. Okay, so we can just do delta encoding of I plus plus. And if it is value of star, it is temp, then we don't need to do these extra things. Basically just delta encoding of I plus plus and delta encoding of prefix indexes of star it plus 1 minus minus is okay. So prefix indexes prefix sum indexes is like it stores the index of the prefix sums at where what index is that prefix sum uh, present. So that is basically the map. And uh, if this is not equal to temp as well, not end as well, so we can do delta encoding of I plus plus, delta encoding of prefix indexes of star it minus minus, and we need to add some remaining t of remaining t to that bj. We discussed it, right? So here basically these guys drank to their limit from ai, and if some t was left, we need to feed it to bj plus 1, right? So that is basically this thing doing answer of index plus is equal to temp minus temp I, tempi, or whatever it is. And finally this is prefix sums of delta encoding vector, so prefix summing it. And finally answer of I plus is equal to prefix sum into this bi, and finally outputting the answer. I'm using the one based indexing in this solution or this implementation. These are some nice debugging statements or illustrative statements of this cout that I've used to clarify the code more in more nice way. You can definitely uncomment them and check how the code is working and what dynamics is the code following. So that was it. Uh, this is the solution. Hope you enjoyed it. Thank you for joining the channel. Thank you for watching the video. Like the video, stay subscribed. Nice to see you on the boat.